This is less electropositive, electropositive, and this one is highly electronegative, highly electronegative, okay. So when they are just going to make the bond like fluorine, oxygen, nitrogen, chlorine, okay, they are going to make bonds with some other elements. They generally attract the bonded of pairs of electron towards itself, as a result of which, due to attractions of these electrons, okay, this the electron actually should remain in between, like here and here, but this moves slightly away from this one. It should be here, but it moves here, okay. As a result of
Yes.
which, we can simply say here that due to that, uh, this bonded pair of electrons shifted towards the chlorine, as a result of which we acquire slightly negative charge on this one and slightly positive charge on this one. This is called poles. The poles are developed, okay. You
Yes, sir.
understood? The poles are developed, and since the poles are developed, then we'll simply say that if the poles are developed, then we'll simply say that this is a polar compound, okay.
Yes, sir.
You understood? We will consider
Yes,
it
sir.
polar compound. So polarity is developed. But in case of hydrocarbon, like we are talking about hydrocarbons or some other, okay. So in this case, carbon is not so electronegative in nature. So in comparison to this carbon and hydrogen, the bonded pair of electrons are not attracted much towards a single atom. Okay. Okay.
Yes, sir.
As a result of it, we will simply say here that in this case, the bonded pair of electrons will be not shift to any one of them, so it will remain unpolar or non-polar. Okay, got it?
Okay.
So the
Yes,
polar
sir.
substance, like for example, ethanol. Ethanol is a carbon compound, but it get easily dissolved. Okay, in water.
Yes.
Why? Because water is a polar solvent. In water, there is an electronegative element. Okay, and this is a positive, slightly positive, and this is slightly positive. Similarly, ethanol, C2H5OH, C2, or we can say CH2, CH3, then O, and then H. Okay, and this H and this O has a negative charge, positive charge. Okay, so there is an attraction between this one. So this polarity, this negative and this positive hydrogen get bond together. Okay, and we will simply say that they are just making the bond here, as a result of which this is called hydrogen bonding, hydrogen bonds. Okay, so this hydrogen bonds between this electronegative and electropositive element make it ethanol to dissolve in water. Okay, otherwise other hydrocarbons does not dissolve in water. Okay,
Yes, sir.
got it? So here in the insert it is written that, but in we are just going to, in this chapter, we just generally going to study that liquids dissolution, we can say simply gas dissolutions in liquids. Okay, not the liquid dissolution in liquids. We are not going to study in this chapter. We're just going to study all those reactions in which liquids, okay, liquid solution, but generally we're just going to focus the dissolution of gas in liquid. Okay, we are just
Yes,
generally
sir.
going to focus the dissolution of gas in liquids.
Liquid.
Okay, so now moving further, the dissolution of gas in liquids is generally explained by Henry's law. Okay, Henry was the one who gave this law, and he said that according to Henry's law, note it down. Stop it.
Okay,
Henry,
sir.
Henry law. Okay. So what does Henry's law state that? Henry's law talk about the dissolution of gas in liquids. Okay. So it defines the solubility. It defines the solubility of gas in liquid solvents. In liquid solvent. Okay. And
Yes, sir.
this time in Ramadan, you are just preparing solutions. Okay. Like you are just making ruh afza and other stuffs. Okay. So it's things. Sharbat, we generally call it in Hindi. So you generally dissolve sugar in the liquids in the water. Okay. So do you think that in the cold water will it dissolve more betterly or not?
No, sir.
No. You need a warm water, and then you dissolve the sugar into it. Then you can add the ice to it so that it can get cooled. Okay. But
Yes, sir.
in the cold water, it get very difficult. So if I talk about the
Ye-
solid substance dissolution in liquids, we will simply say that the temperature, on increasing the temperature, the solubility of solid increases with increase in temperature. Okay, solubility of solids in liquid increases with increase in temperature. So if I write it, one point here is that solubility of, just stop it. Solubility of liquids, of solids in liquids increases with increase in temperature. Okay. But if I
Yes,
talk, because Henry's law talk about the dissolution of gas in liquid. Do you think that if you increase the temperature, the solubility of gas increases or decreases when you are adding it, when you are dissolving the gas in the liquids?
I think decreases.
Will decreases. Do you think that the aquatic animals that lives in the pond, okay, will they able to survive more better in the aquarium that is having colder water or the hotter water?
Colder water.
Colder water, because the solubility of gas, because the aquatic animals uses dissolved oxygens in the water. Okay, and
Yes,
if we increases the temperature, or if we add some warmers, if we add hot water to the lakes or to the ponds from the industries, then this will decrease, because the temperature, if the temperature increases, okay, if the temperature increases, then what is going to happen? Simply, the temperature of the lake will increase, and this will decrease the solubility of the substance, solubility of the
yes,
gas. So we'll simply say that the solubility of gases in liquids dissolves, and in liquid decreases with increase in temperature, decreases with increase in temperature, increase in temperature.
mm,
And what does the Henry's law say? That Henry's law says that the solubility of gas, okay, the solubility of gas in liquids is directly proportional to the pressure applied over it. Means
yes,
the pressure of the gas applied over the surface of the water, or the over the surface of the liquids in which we are dissolving. Okay, so what does it say? That the solubility of gas in liquid is directly proportional to the applied pressure over the surface of the liquid. जितना आप,
yes,
the more pressure you are just applying on the surface of the liquid by the gas, the more the gas will get dissolved.
yes,
Okay, you understood?
yes,
Understood?
yes, sir.
Please note it down that it state,
Okay, sir.
according to this law, the solubility of gas, the solubility of gas in liquids solvent is is directly proportional proportional to partial pressure of that gas over the surface of water, over the surface of water.
Okay, sir.
So we can say that the weight of the gas that is dissolving here, weight of the gas that is dissolving here, or mass of the gas, you can consider it, is directly proportional to the pressure of the gas over the surface. Okay, so we can say that the pressure of the gas is directly proportional to Kh, the Henry's constant, Kh, into X of the gas, where X is the mole fraction of the gas, where where X is the mole fraction, mole fraction of the gas. Okay, means what does it says? It simply says that the weight of the gas, the weight, the amount of the gas that you are dissolving in the liquid, it is directly proportional. It is directly proportional to the pressure of the gas applied over it. Okay, over the liquids by the gas. Okay, and here it says that the pressure is directly proportional to. Okay, now if I'm saying that this thing, this is the Kh value, Henry's constant. Okay, this is the Henry's constant, and you know that this is a unitless quantity, right? This is the unitless quantity. This do not have units, so it is a unit. Mole fraction does not have any unit because it is the number of moles divided by number of moles. So number of moles will cancel out with number of moles, means the mole will cancel out. There will be no units. Okay, so we'll say that it is a unitless quantity. Unitless quantity. So what can be the unit of this one? Kh. It is pressure. So pressure can be equated with pressure. So it should be in the pressure. Okay. The unit of this one is pressure. Pressure means like it can be the similar units that of like atmosphere, pascals, bars, etc. Okay. You understood?
Yes, sir.
So it is pressure. Okay.
Yes, sir.
So if I say that here this is the product. Okay. And you know that if I'm applying 200 atmospheric pressure on a gas, like for example, on a gas, okay, it is Kh. If I'm just multiplying here, just try to concentrate here. It is important. Okay. So if I'm
Yes, sir.
writing here Kh for A, okay, Kh, this is K means constant, H for Henry constant for A gas is this one. It is given. Now, you know that 200 can come if I'm just applying 200, same gas, same pressure, 200 atmospheric pressure. I'm just applying for the KHB, for the MB. Here the value for B gas is this one, and this is the gas B. It is showing this show. Just a minute. This is the gas B. Okay. Just
Yes, sir.
now the mole fraction that I dissolve for this one is 0.2 mole. Or and for this one, I am able to dissolve for this one is 0.5 mole. Okay. So what will be the value of this one? What will be the value of this one? In the upper case and the lower case. So you can find that the value of this one, if A, the mole fraction, you know the mole fraction of this one is more as comparison to this one. Means that at same pressure, you are able to dissolve more moles of B. The mole fraction of B is more at 200 pressure. Means the solubility of B is more as comparison to solubility of A. Mole fraction is solubility. Okay.
Yes, sir.
Sure. So I just want to concentrate here one thing, that if you write 200 divided by 0.2, what you are going to get? You will get 1000. Okay. And for this value,
Yes.
what you are going to get? 2200, sorry, divided by 0.5, will get 110 here. Okay. And you this cancel out each other, you will get 40. 14 today, you will get 400 only. So here the value of this one is 1000. 1000. And here the value of this one is
400.
400. So you see here that here the value is more, so the mole fraction is less. And here the value of this KHB for the KH, the value for the KH value for B is less. So here the mole fraction is more. So we will simply say that more the value of KH, Henry's constant, less will be the solubility of that gas in the atmosphere, in this liquid solvent. Okay. So simply note
Yes,
it
sir.
down. More the value of KH, more the value of KH. Okay.
Yes, sir.
and Henry constant, lesser will be the value, or lesser will be the value of mole fraction or solubility. Lesser will be the solubility. Lesser will be the solubility. Lesser will be the solubility. In the liquid solvent. Let's take a question over it. As you are very much familiar that the saturated solution and unsaturated solution, you know now, as you have been studying from the 9th standard.
Yes, sir.
Do I need to write out this one?
Sure, sir.
Hmm? Okay.
Yes, sir.
Okay, let you write it. A definition. Just going to explain the saturated and unsaturated solution. Okay, we are just studying this one. Okay. Now you know that we are just going to saturated solution is the solution in which we will simply say that when you keep on when you are dissolving solid or something in a solution, then in a stage come, then it will all the intermolecular space will be filled and no more solute can be added to the solution. Okay, no more solute can be added. So we'll simply say that saturated solution is a solution that when a solution comes in a state where no more solute can be added. Okay, no more solute can be added. Okay, this is called saturated solution. Okay, you understood?
Yes, sir.
Okay, now what does the Leach-Attrier principle says that here for the solubility of gas? Simply, let me explain you that one also. That according to the Leach-Attrier principle, what does Leach-Attrier say that? Let me explain. The effect of temperature on the solubility of gas. Okay. Yeah, this portions are easy portion from the NCRT, so I'm just taking this one from the NCRT as it is. Okay, so if I'm saying that Leach-Attrier principle, what does the Leach-Attrier says that? He says that, for example, if in a reaction, okay, if A plus B, yeah, so if you are dissolving A to B and C is formed, okay, and it result in the formation of heat, means heat is released during this reaction. Okay, heat is released during the reaction. Like for example, you are dissolving something and heat is being released. So that reaction will proceed further if you remove the heat from this one. Means this reaction will keep on moving in the forward direction. If you remove the heat, means removing the heat means that if you keep this something that start absorbing the heat. Okay, like for example, if you are dissolving a solute to B solvent, okay, to B solvent, and you find and you notice that there is an increase in temperature. There is an increase in temperature. So if you want to keep the A to dissolve more and more A to dissolve in B, you need to reduce the temperature of this one. You need to reduce the temperature. Okay, this reaction will be very much means it can go forward if you remove the temperature. And how will you remove the temperature? Just to keep this reaction in the colder area. Means just you need to proceed this reaction in those areas where, or just keep around the ice so that it can absorb. Okay, so it's a simple, this reaction will proceed when you absorb the heat. The released heat is absorbed. Okay, or we can simply say that this reaction will not proceed further if you keep on adding the heat. Okay, because heat is added. So when heat is the product, heat is obtained in the product. It is obtained in the product, okay. So if something is obtained in the product and you give it in the reactant, then the reaction will not proceed. Like for example, if I'm saying that A plus B for the same reaction, and if you keep giving the heat here, okay, this reaction will not work, will not proceed. Okay, it will try to move in the backward direction. It will move when you provide the heat to it, it will goes back. So you need to okay, if you provide the heat, it will goes back. Means it will separate A and B.
Yes,
Okay.
sir.
So for example, if you dissolve gas, you can check the there is in India there are soda means there are soda means on the streets we find that there are soda selling means we in Hindi we say thela. Okay. And
Yes, sir.
here are some they used to use the pressurized gas. You can see on the YouTube they used to give the pressure. They used to pass the carbon dioxide gas to the uh, water that is filled in bottles. Okay, this is called soda water. And then they
Yes,
add some cola powder to it to make an artificial cold drink. Okay. So
yes, sir.
this, when you find that bottle, when you pass the heat to it, then you will find that this bottle become heat hotter. Okay. So this simply indicate that that A plus B, when B is gas, okay, when A plus B, when B is gas, okay, and A is liquid, okay, or here we just took the solute as A, so we can take A as gas. Just take as A as gas, A as gas. Okay, it is solute and it is liquid. So the temperature, when C is formed, the mixture of this one, C is a mixture, then heat is released. Okay. So simply I was explaining you this one, that according to Le-Chatelier principle, if the heat is released, then this reaction will be favorable as when the heat is being removed. Means this reaction will be more favorable when you remove the heat. Means it will on decreasing the temperature, this reaction will proceed. So that's why the solubility of gas in liquids is more feasible, okay, occurs more in a better way when the temperature is less. Okay, because this
Yes,
is an exothermic process. So in the exothermic way, all the exothermic process will be feasible if the heat is being removed from that. Okay, they are feasible at low temperature. Okay, you understood? Are you
yes,
getting this one? Now, for
yes,
example, if you are dissolving NaCl to water, that the temperature will decrease. Temperature will decrease means it will absorb the heat. Okay, like for example, temperature decrease means that it will absorb the heat from the moisture in return from the surrounding body. Like for example, if I'm feeling a glass having ice in it, I'm feeling colder it. Why I'm feeling cold? Because it is absorbing the heat of the utensil that in which it is kept. That's why I feel it colder. Okay, so means it is
yes,
utilizing the heat. So for example, if I'm having A as a solid like for example NaCl, and if I'm dissolving it into water, okay, then the temperature, then it will gives you C as a brine, okay, and the temperature decreases. So temperature will decrease means it is absorbing heat. It is absorbing heat. Okay, it is absorbing heat. So we'll say that if the some substance is absorbing heat, so it will be absorbing heat means heat it is using during in the reactant. Heat it is using in the reactant, not in the product. Heat is used in the reactant. Heat is used in the reactant. Okay. So heat in
yes,
the
sir.
used in the reactant means it is an endothermic reaction. Endothermic reaction. So all the endothermic reactions, if the dissolution is endothermic process, then it will be feasible at high temperature. Means the more solute you can dissolve it at high temperature, like if you are dissolving salt or sugar in water, it is more feasible. It is more feasible that if you do it in the warm water. Okay, but since dissolution of gas in liquid is an exothermic process, so it is more feasible according to the Le-Chatelier principle. It is more feasible if it is done in the uh, low temperature. Okay, so this is the simple. The Le-Chatelier principle says that the solubility of solids in liquid is significantly affected by the temperature changes. Consider the equilibrium represented by the equation 10.1. Okay, this is a dynamic equilibrium. Must show the Le-Chatelier principle in this journal. If in a nearly saturated solution, the solution which is nearly saturated, okay, means nearly saturated, and if you want to dissolve more salt to it, then if that process is exothermic, then if that process is exothermic, like for example, if you have already dissolved some gas in the solid substance, sorry, in the liquids, and you want to dissolve more gas to it, then you have to lower the temperature. But if you are having a salt solution which is already nearly saturated, and if you want to dissolve more salt, then it will be more feasible at the high temperature. Okay, more salt can be dissolved at high temperature. You understood this one?
Yes, sir.
Okay, so let's move further. We were just moving towards the Henry's law. Okay, just a minute. So here is the table for the helium. Okay, at temperature, the temperature is given, all are 293 or 298 Kelvin temperature. Okay, so here the value of kh, Henry's constant, or K in bar, the unit is kilobar. Okay, so in this unit that you find that helium, this one is given to you, and this value. So we can say that the substance which has lower value of kh, it is more soluble in water at that temperature. Okay, so like this value is very less. Okay, so here if you dissolve this gas in water, it will be more soluble. So lower the value of kh, more will be the solubility. Okay,
Yes, sir.
you understood? Now just take an example for this question, for this one. So here is the question. Please try to solve this question. What is saying here?
Um,
What is saying that question?
H2S is a toxic gas with rotten egg-like smell. Is used for the qualitative analysis if the solubility of H2S in water at STP is 0.195 m. Calculate Henry's law constant.
Find the Henry's law constant. Calculate the Henry's
Yes.
law constant. So you have to calculate the Henry law constant. So what is given to you? That this is the small m. What does small m represent?
Um,
What does the small m represent? Small m represent the molality.
yes, sir.
Molality, okay? And that is 0.195. What m, okay? So if I ask you what information did you get from this one? It means simple that 0.195 moles of H2S is dissolved in 1 kg of solvent. And if solvent is not given, we assume that solvent is water. Okay,
Yes, sir.
understood? Now you need to calculate the mole fraction of SO2, H2S, sorry. So what can be the mole fractions? So mole fraction, you remember mole fraction of H2S will be equals to number of moles of H2S upon number of moles of H2S plus number of moles of H2O. Okay. Now just consider here. What is the number of moles of it is given to you? That is 0.195. Okay. And it is 0.195 again. And then it is we how many moles, number of moles of water will be there in 1 kg? Number of moles, calculate the number of moles of water in 1 kg of solvent. And that you need to keep in mind always. Okay. Try to calculate how many number of moles of water will be there in 1000. What is the formula of the number of moles? Number of moles is equals to given mass upon molar mass. So it is 1000 divided by 18. You cut it, you will get 55.55. Okay. So you will get 55.55 moles. Okay. You understood?
Oh,
Just always remember that 1 kg of water, 1 kg of water have 55.55 moles. Okay.
yes, sir.
So you add this to you will get what? You will get, since sometimes this value is very small, then like you check it, this value is very small, okay, as comparison to this value. You can neglect this value, okay? But if you try to add, you can add this one also, okay? This is 0.195 divided by, otherwise you can neglect this value, because when the number of moles of solute is very, very less as comparison to the number of moles of solvent, then we reject the number of moles in the denominator only, okay?
Yes,
Okay.
sir.
Because adding 55.5 moles with 0.195, it is very less quantity. So you can assume this one 0.2, you can assume that this is approximately will be equals to 55.70. You can assume this one as 20.20 and this will be 75. Okay.
Yes, sir.
Okay. So this is the mole fraction. Now you get this value of mole fraction.
Yes,
Okay.
sir.
You understood?
Yes, sir.
Now, what is the Henry's constant? P is equals to KHX. Now, H2S gas, you need to find out pressure. How much pressure is given to you? Proton egg is used for quantitative if the solubility of sugar at STP, a standard temperature and pressure. So at STP, we'll simply say that the pressure is 1 atmosphere, okay? 1
Yes, sir.
atmosphere. So we assume that the pressure is 1 atmosphere at standard temperature and pressure. So at STP, the temperature is 25, 293 Kelvin, 25 degrees Celsius, or 293, 298, sorry, 298 Kelvin. Okay, this is the temperature at STP and the pressure is 1 atmosphere. Okay, so you can assume this one as 1 atmosphere and you need to find out the value of KH, and you need the value of this one 0.195 into 55.75. So when you cross multiply this one, you will get this value. So you will get 0.195 upon 55 point, sorry, this will goes to that side. So you will get 55.75 divided by 0.195 is equals to KH. Okay. Now find out the value of this one. Try to find out what is the approximate value. Just tell me the approximate value. I will be satisfied with that one. Tell me the approximate value.
Yes,
You
sir.
can
One
assume in the
natural.
rough that it can be 55.75 will be equals to 0.20. Can you assume this one this
Okay.
like this way? Hmm?
Yes, sir.
Now this is 75 and this is 2. Okay, just remove the decimal after the 2 place. This will be 55.75 upon 20. Okay. Divide this. This is 74. You can assume this one as 74 also. You can assume this one as 74 because we have added 19.5. So you can assume this one as 74 also. It's your choice. It after a decimal second digit, not in the first digit, you can change the value. It will not create the much difference in the answers. Okay. So if you
Yes,
change this
sir.
value because you are increasing the lower value, so you can, okay. So you can increase the upper value. So you can make it 76. Just make it 76. It will not create much problem. Just assume that it is 76. Okay, now divided by 2. Now it is divisible. So divided by 2, you will get 55.76 divided by 2. You will get 2, 2s are 4, 1 carry 5, 15. Then you will get 5,
Seven.
15. Okay, then you will get 7s are 14. Then 1, then 17, then 8s are 16. Then 1, then 16, then 8s are 16. And then you have to play the decimal after. The answers in, you have to play the decimals after 2 digits. It will be 27.88. Okay, got it? Upon 10. So you will
Yes,
get 2.78 atmosphere. Okay,
yes, sir.
2.78 atmosphere. You understood?
Yes, sir.
Next similar question on this one. Did you copy the previous one?
No, sir, I was copying it down.
Please copy this one. Yeah.
Yes, sir. So can you show the question also? I had to copy the last part.
Please don't take the screenshot, Thameem, है ना? Because it will not,
Yes,
because you are studying right now, okay? Don't think, let the things pending, okay?
yes, sir.
Try to note it down. You done?
Yes, sir.
This one also?
Yes, sir.
Okay. Do this one. Try to write the basics of this one. Just write down the question and try to
Okay,
get the
sir.
information that is given to you.
Yes, sir. I have noted it down.
Okay. Try to get the information that you find out from this one. To get the information. And Tamim, note this one first, that they are a different unit. Like we have the units of masses, okay, and we have the like mass is measured in kilograms, okay,
Yes,
but
sir.
pressure is measured in different units, okay. So that you need to keep in mind that one atmosphere atmosphere is equals to 10 raised to the power 5 pascals. So these are all equals that standard unit of pressure is atmosphere, or we can say that pascals also. Sometimes it is written pascal, sometimes it is written in pressures. So sorry, atmosphere. So there are different units. Okay. So you need to
Okay.
concentrate here that one atmosphere, sometime like one at ATM is equals to 10 raised to the power 5 pascal. That is equals to 1.01. Actual value is this one. Okay. So we write generally 10 raised to the power 5 pascal because this value is approximately equal to 1. Okay. Got it? Got it?
Yes.
And that one atmosphere is also equals to 760 mmHg. mmHg, that is also equals to, if it is, that is also equals to 76. Instead of mm, it becomes centimeter Hg. Okay. And this is also equals to bar. That is 1.01. Okay. Bar. One atmosphere is equals to approximately bar, and atmospheres ATM is approximately equal. Okay. So it is one
Yes.
atmosphere is approximately equal to 0.013 bar. You can write it up to the 3 decimal place. Okay, so it is in bar. So note down these values. These are important.
Okay, sir.
So now this value is written in pascals and temperature is written in Kelvin. So temperature we don't require here. Okay. Calculate the quantity of CO2 in 500 ml of soda water when packed under the atmosphere of 8.5. Okay. So what is asking? The quantity of CO2 means it is asking the amount, mass of CO2. So how can you, first of all, you need to find out the mole fraction of CO2. Okay. You got
Yes,
it?
sir.
First of all, you need to find out the mole fraction of CO2. So how can you find out? The Henry law constant in water, it is given to you, this one, for CO2. So Henry law constant is given to you. Now you need to find out the pressure. The given pressure is 2.5. First, always write the biography. If it is given in atmosphere, ATM, then write in ATM. If it isn't given in pascals, okay. But here, one thing you need to concentrate here, that this temperature is given in pascal, and this pressure is given in pascal, and this atmosphere, this pressure is given in atmosphere. So you can either convert this one into atmosphere or you can convert this one into pascal. But you cannot do like this. Okay. What I'm saying here is that you cannot use one thing in pascal in the same question, another pressure in the atmosphere. You cannot do this. They must be in the same. Like while you are calculating one value, you are putting in grams, the other value should be put in grams. You cannot do that 2 kg when added to 5 gram. So it will give you 7 watt. You have to convert this one into grams, sorry, into kg, or you convert this one into grams. You have to make the unit same, na, so that the calculation can be better. You understood what I'm
Yes.
saying?
Yes, sir.
Okay. So here, 2 point. So just convert this atmosphere into Pascal so that if this value is given in Pascal, so you can do this one also in Pascals. Okay. So
Yes, sir.
2.5 atmosphere will be equals to how many Pascals? So I told you that just give this, raise this power with 10 raised to the power 5, then it will convert it into Pascals. Okay. Here, 1 atmosphere is equals to 10 raised to the power 5 Pascal. Okay. You understood?
Yes, sir.
Are you getting this one? Each and everything that I'm teaching you right now.
Yes, sir.
Okay. Now the given pressure is this one. Is it okay? Now what is the value of kh?
Okay.
What is the value of kh in the given question?
Um,
Kh. This
okay.
is Henry's constant. Henry's law's constant.
It's 1.67 into 10 to the power
Yes,
8.
1.67 into 10 raised to the power 8 pascals. Okay. Okay.
Yes, sir.
Now mole fraction. First, you need to calculate the mole fraction of CO2. Mole fraction of CO2. So what would be the mole fraction of CO2? Just divide it. You will get the value, exact value. Okay. So this
Yes,
is
sir.
very simple. First of all, you need to find out the mole fractions. or unit, or you
Yes,
can
sir.
calculate the number of moles directly by putting the value, okay, of CO2. So, and this is the solubility is not, means since this value is very large, okay, so more the value of KH, the lesser will be the solubility. Okay, so just you put this formula like this way, that P is equals to KH, and is the constant for CO2 into X, mole fraction of CO2. Now P is given to you, that is 2.5 into 10 raised to the power 5 Pascal. KH is given to you, that is 1.67 into 10 raised to the power 8 Pascals, into you need to calculate the X, mole fraction of CO2. So mole fraction of CO2 can be easily calculated. What it's saying here, the calculate the quantity of CO2 in 500 ml of water, 500 ml of soda water. Okay. So the total weight of the soda
Yes.
water is 500 ml. Okay. 500 ml. So just concentrate here that we need to calculate the number of moles of CO2, or you can calculate the mole fraction separately in the right hand side also. Okay. So just you write it like this way. Yes, I'm going to, this is X CO2, and this value will goes down. You will get 2.5 into 10 raised to the power 5 upon 1.67 10 to the power 8. What value did you get from this one? Try to calculate it.
Sure.
Try to calculate. Just remove this decimal and this decimal, and try to get the value of X CO2, mole fraction of CO2. Me, what answer you are getting?
I
This
haven't
8.
got the answer.
You got the answer,
No, sir, not yet, sir.
right? You will get 10 raised to the power minus 3 when this 8 power will goes up. This, that base is same. And when this is power, this goes up, it will give you 10 raised to the power 5 minus 8. You will get 10 raised to the power minus 3 for this one. Into, that is 25 divided by 16. So you divide 25 by 16, simple. Okay. So when you divide 25 by 16, what you will going to get? 16 ones are 16. Then you will get 9, then decimal, then 0, then 16 fives are 80, then 10, then already 0 here, then 16 six are 96, then 4. Okay, so you will get 1.56 into 10 raised to the power minus 3 is equals to X CO2. This is the mole fraction of CO2.
Yes, sir.
Okay. Now what is asking, that calculate the quantity of CO2 in 500 ml of soda water. Okay. So quantity of CO2 it is asking for. So since the mole fraction, the number of moles, now you can estimate here that the value of this one is very less. As comparison to C, you can see that if I ask you that the mole fraction of water in this one will be 1 minus this value. Okay, this is the mole fraction of water. Mole fraction of water.
Yes, sir.
Okay, when you subtract the mole fraction of solute, means this is mole fraction of solute, mole fraction of solute, plus mole fraction of solvent, it is always equals to 1. So if you know the mole fraction of solute, okay, then you subtract it here like this way, 1 minus 5.6. This is the mole fraction of CO2. This is solute. So you will get the mole fraction of water. So you will get this value as very less because it is 10 to the power minus 3. That is 1.5600, this value. This value is very less. Okay. So we will simply say that the mole fraction of water is very, very large as comparison to this one. You understood now? Understood?
Yes,
Now
sir.
we need to find out the actual mass of CO2. Just concentrate here. This is important. Then you need to do this question again by your own. Okay. You need to
Yes,
find
sir.
out the moles, the number of, so first of all, you need to find out the number of moles of CO2. So the number of moles, you find this value, that is X CO2 X CO2. The mole fraction of CO2 will be equals to what? Number of moles of CO2 upon number of moles of CO2 plus number of moles of water, H2O. Okay.
Yes, sir.
Okay. You understood?
Yes, sir.
Now this number of moles of CO2 you have to add. So you have to find out this one. So you write number of moles of CO2 like this way. Okay. But this number of moles of CO2 is very, very less as comparison to the number of moles of H2O. So when the number of moles of H2O is very, very large that comparison to the number of moles of CO2, okay, then we we neglect the number of moles. We neglect this value. We neglect this value only in addition. Only in addition. Only in addition. Okay, so we will write here number of moles of water. Got it?
Yes, sir.
Because it is having very less amount of, means the weight of the mass. Actually, gas is very light in weight. Okay, the amount of CO2 that you are dissolving only in 500 of ml of water, it is very less. Its weight can be neglected. Okay,
Yes, sir.
you understood?
Yes, sir.
And there you find the value 1.56 into 10 to the power minus 3 here. This is the mole fraction of CO2. Now the number of moles of CO2 will be equals to what? How many moles of water will be there in 500 ml? In 500 ml, just we come to know here that in 500 ml, CO2 is also present.
Yes,
Okay,
sir.
CO2 is also present, but the weight of CO2 is very less. So we are just neglecting that in the 500 ml of water, the most of the weight is of due to water. Okay.
Yes, sir.
Okay. And you know that the weight of the water, we need to write out to calculate the number of moles of water, we need to write down the uh, given mass upon molar mass. So it is 500 ml, not the mass. So you know, since the water has density 1, so we will say that 1 ml of water will have 1 gram weight. 500 ml of water will have 500 gram weight. Okay. Because density is equals
Yes,
to
sir.
mass upon volume. Mass upon volume. So when this is equals to 1, so 1 is equals to mass upon volume. So this will go to that side and will give you mass is equals to volume. So simple. If it is written in ml, then it's okay. We will consider it as in grams. Okay. If it is written in ml, then it's okay. It is 500 grams. Now I told you that in 1 liter or 1000 gram, then how many moles are there of water? That is 55.55 moles.
Yes, sir. 55.5.
So how many moles are there in the half liter of water? That will be the half of this one.
Yes, sir.
That will be 27.27 something.
Yes, sir.
Okay, so you can divide it at 27.5. 50, half of 55 is 27.5, and half of this one is, you can consider this half. So you will get the value 27.7. Okay, approximately you will get this value. When you divide it by 2, you will get this value approximate. Okay.
Yes, sir.
Now multiply this value to that side. You will get 1.6 into 10 raised to the power minus 3 into 27.7. Okay.
Yes, sir.
7.7. This will goes to that side. So when it will goes to that side, okay, this will gives you the number of moles of CO2. Okay. This is the molarity. So you write it like this way. You will write 1.56 into 10 raised to the power minus 3 into 27.77 is equals to number of moles of CO2. If I ask you the weight of the CO2 that is dissolved, so you know the formula of CO2, the formula of the weight of the CO2 that is going to dissolve is that is number of moles. Number of moles is equals to given mass upon molar mass.
Yes, sir.
Upon molar mass. Okay. So if you need to find out the obtained mass and you know the number of moles and you know the molar mass, so you just multiply this number of moles of CO2 with the molar mass, you will get the value. So you will get the weight of CO2 dissolve, weight of CO2 dissolved will be equals to 1.56 into 10 to the power minus 3 into 27.7 into 44. 44 is the molar mass of CO2. 44 is the molar mass. Molar mass of CO2. Okay, so you just multiply this one with the number of moles, you will get this value. Okay, so
Yes,
approximate
sir.
what value you are going to get here. Check it. Try to check it.
Yes, sir.
Because in NCRT the exact value is written. Okay, in the examination you will get some values that can easily be divided. Okay, so don't think that it is very tough. No, it is not tough actually. You are just in a learning state. That's why you think.
Okay, sir. Um,
What value did you get here?
so I think I made a mistake, so I'm doing it again, sir.
Okay. Good, please.
What, sir?
Keep doing. Okay.
Yes, sir. Um, so can you do this for me? So I think I'm stuck.
So when you multiply this one, you will get simple. You multiply these two terms. Okay. First, this is 27.7 multiplied by 1.56. Okay. So when you
Yes,
multiply this one, you will get 6 sevens are 42. 4 carry. Then 6 sevens are 42 and 4. 42 and 4, 46. 4 carry again. 6 2s are 12. 12 and 4, 16. Okay, then 5 sevens are 35 and 3 carry. And 5 sevens are 35 and 3 38. Again 3 carry. Then 5 twos are 10 and 3 13. Okay, then again you will get, when you multiply, you will get 7 7 2. Okay, then you get 2, then 11, 1 carry, then 7 8 15, 15 and 7 22, then 1 carry, then 5 and 7 12, then 1 carry, and then you will get 4. Okay, you are getting 4 point, and you will place the decimal after 3 digits here, because 2 from here and 2 from 1 from here, 2 from here. That is 42.12. Now you have to multiply this number by 44.
Yes, sir.
Okay, so when you multiply this number by 44, 42.212, when multiplied by 44, what you will get? You will get 4 twos are 8, 1 carry. So no carry. 4 ones are 4. 4 ones are 4 twos are 8. And 4 twos are 8. And 4 fours are 16. Okay, again the same number. 8, 4, 8, 8, 6, 1. You will find 8 and 4 to 12, 1 carry. Then 12, 13, 1 carry. Okay, then 16, 1, 17, 1 carry. Then 15. Okay, then 1 carry. Then 7, 8. Okay, 8,
Yes, sir.
8. So approximately you will get 19 point something. Okay, means this, you have to place this value. You have to put the decimal after 3 digits. 1, 2, 3 here. Okay,
Yes, sir.
okay, and this is 1857.32 into 10 raised to the power minus 3 is also here. So you have to put the decimal to this place. You will get 1.85, which is approximately equals to, okay, 1.85 grams, which is approximately equals to 1.9 grams. Okay,
Okay, sir.
got it? 1.85 grams or 1 point something grams you are going to get it. Is that clear?
Yes,
So
sir.
this 500 in 500 ml of CO2, we are just only able to dissolve only 1.5 grams of CO2, because CO2 is very lighter in weight. Okay. So now
Yes, sir.
let step by step, I'm going to explain you this question again. Just concentrate here. Okay.
Okay,
That is
sir.
the Henry's law. You that this is given to you. That is 2.5. What is given to you? This is the temperature. Sorry, pressure is given to you. Okay, and this pressure is in the ATM, and this Henry's constant is given in pascals. So what you are going to do here? Tell me. You have to convert this one. Okay, into the pascals. So you convert this one into the pascals. Okay.
Yes, sir.
By just multiplying, because one atmosphere is equals to 10 raised to the power 5 pascals. So you just multiply the atmosphere value with the 10 raised to the power 5, we will get in pascals. Now the KH value is already given in pascals, so we write it in pascals. Okay. Now you need to find out the mole fraction, because it is asking for the weight. So for that, you need to find out the number of moles first. So you write the formula that pressure is equals to P is equals to KHX, where X is the mole fraction of CO2. You just put the value, the pressure, given pressure, you put the value here. That is 2.5 something. That is the given pressure that is under which the reaction is taking place. Then you put the Henry's constant value, and then you give this CO2. Okay, mole fraction of CO2. Now this will goes into the denominator. So this value goes up. So there will become -3. And when you divide this number here like this way, 25, you, because the decimals goes. Okay, this is 1.6. Okay, this is 1.67. I just put it 1.6.
Yes, sir.
Okay, it's okay. Here is a mistake, but you means the value is approximately same. Okay, it should be
Yes, sir.
1.7 something. So I just put 1.6 to for the easy calculation to make you understood, because in the examination you are not going to get that value, which is not means it will be easy value will be given to you. Okay, now you cut this value, you get this value. Okay, this is the mole fraction of CO2. Understood?
Yes,
Understood?
sir.
This mole fraction is very, very small in size. You can say that it is 10 to the power -3, which is approximately equals to this. I have written here somewhere. That is 0.00156. Means when you put the decimal here, the decimal will shift to the 3 digits. So this is very small in number. So means the mole fraction of CO2 is very, very small. as comparison to the number of mole fraction of water. So we write the mole fraction of CO2 will be equals to the number of moles of CO2 upon number of moles of CO2 plus number of moles of water. But this value will be rejected. This value will be rejected here. Rejected here. Why? Because the number of moles of CO2 is very, very less in addition. Okay.
Yes, sir.
So we'll reject this one. Then we will keep the value here. We just add only when the number of moles of the solute is more. Okay. But it is very less. So we just reject this one. We just write here the mole fraction of CO2 is number of moles of CO2 upon number of moles of water. So we need to find out this value. We just find out this value. And since the water is given 500 ml, you know the density of water is also 1. Here in this one, the water is also, sorry, CO2 is added. But we are not comparing this one because this mass, this grams is negligible, okay? The mass
Yes,
of
sir.
CO2 is negligible. So we just assume that the total mass of the water is 500 and that is equal to 500 grams because density of water is how much? Density of water is uh, the density of water is 1. So that's why we will simply say that the ml will equals to 500 ml will equals to 500 grams. Okay. So we just write here. Now you know that 1 kg of water has 55.5 moles. Okay. So the half of this kg will means 500 ml or 500 gram is going to have this number of moles. Okay. You
Yes,
understood?
sir.
So we just multiply this way and we get the number of moles of CO2. So we just multiply this one. Now you know that we need not to find out the number of moles. We need to find out the weight of CO2. So you know the formula that number of moles is equals to given mass upon molar mass. Okay. So what we
Yes,
did here is that simply we just multiply this molar mass to this number of moles. Okay. You will get the mass. So number of moles we have find out here. This is the number of moles. Just we need to multiply the 44, the mass of CO2 with this value. And you will get the number of moles. So when you multiply it, you will, you will get the weight of CO2. Okay. The weight of CO2 is this one. When you multiply all, you will get this value.
yes, sir.
Understood?
Yes, sir.
Sure.
Yes, sir.
Okay. Try to solve one more question that I'm going to give you. Then we will write some important tips. Try to solve this one.
Okay, sir.
Now it is now this pressure is given in bars. Sometime in bar, sometime in kilobar, sometime ATM. So you need to keep this one in that the things that if the pressure is given in bars, so the KH value will be also in bars. Same unit will
Yes,
be
sir.
there. Okay. Even though if it is given in kilobar, then you have to convert it into bars. What is saying?
The mole fraction, we have to find the mole fraction, I guess. Like the partial pressure of N2 is 0.987 bars,
It is
and
saying,
how much,
yeah,
yes, we have to find how much millimoles of N2 gas is dissolved in 1 liter of water.
okay. So it is saying that N2 gas is bubble in water at 293 Kelvin. Temperature is given to you. How many millimoles of N2 would be dissolved in 1 liter of water? 1 liter of water. Okay, N2 gas. Assume that N2 exert a pressure of this one bar. So you can write that the pressure of the it is given that 0.87 bar. Okay. And the given that the Henry constant for N2 at this temperature is 76 kilobar. So you have to write it that the KH value is given to you, that is 76.48 into 10 raised to the power 3 bar. Okay. Because it is kilobar, like if I'm taking 2 kg, so it can be written as 2000 grams. Okay, like it is, we are writing here like this, 10 raised to the power 3. You understood?
Yes, sir.
Understood? Okay. Now it is asking for the millimoles, millimoles. Okay. So you know that gas, in case of gas, if we write here that P pressure is equals to KHX. Okay, we need to find out first. We will find out the number of moles. Then we can convert it in with into the millimoles. Millimoles is nothing but 10 raised to the power minus 3. Okay, so we'll write here
Yes, sir.
mole fraction of N2. We need to find out. Okay, now it is given to you, that is you write the value 0.987. Both the units should be same. If it is bar, so it should be also bar, not kilobar, not atmosphere, not Pascal. They should be both same. Okay.
Yes, sir.
Okay. And here it is x is x in is N2. Okay. Mole fraction of N2. So mole fraction of N2 will be number of moles of, or you can write it like this way. Here, right? Okay. So you can write x N2. Now it will be 0.87 upon 76.48 will be equals to x N2. Okay. Now what you are going to do here is you need to find out the number of moles. So number of moles of N2, this is the mole fraction of N2. This you can find out. This value is already in decimals like here, and you are going to divide it by 76. Means this value is going to give you by 0.00 something. Okay, you are going to get this value. Means this is very very less as comparison to the number of moles of water. Okay,
Yes, sir.
okay. So if we will simply say that for when the value is very less, when the mole fraction is very less, uh, of the solute is very less as comparison to the solvent. So we just write here number of moles of N2 divided by number of moles of water. We don't write here number of moles of N2 also. I can write in the formula here number of moles of N2, but this will be rejected. Okay, rejected. We are not going to add it in the denominator. Okay, so this value, that is 0.987 upon 76.48 will be equals to the number of moles. What you are going to write here? Tell me.
Um,
You need to find out number of moles of N2. So write here number of moles of N2 into
yes, sir.
number of moles of, it is giving 1 kg of water. 1 liter of water means 1 kg water because its density is same.
Yes, sir.
1 liter means 1000 ml. And 1000 ml is equals to 1000 grams if the density is same. So how many moles are there in 1000? Tell me. That is 55.55.
Yes, sir.
Okay. So you need to keep in mind that 1000 liter of water, 1000 grams of water has 55.55 moles. So you will write here 0.87 upon 76.48. Okay. Now you will get 0.98 into 7 upon 76.48 into okay, into 55.55. That will be equals to the number of moles of N2. Now it is asking, it is the number of moles, not the millimoles. For example, you have 2 kg substance, okay, and you need to, I ask you to write the answer in grams. So
Yes,
what you
sir.
will do? You will multiply it by 1000. Now it is in grams. Similarly, if I said that you have 1 liter solution, 1 liter something, I ask you to write in milliliter, ml. So what you will do, you will multiply it by 1000. 1 liter is equal to, then now it is ml. So whatever written in the moles, if you want to convert it into millimoles, you have to multiply this one into 1000. So number of millimoles, millimoles of N2 will be equals to whatever this value you get, you multiply this number also by 1000. So you will get 0.87 into 55.55 into 1000 upon 76.48.
Yes, sir.
Okay. So
Yes, sir.
what value you are going to get here approximately? Approximately what value you are going to get here? So just assume that it is 0.98. Just for example, it is 0.98. Can assume this is at 1.0.
Yes, sir.
0.98 is very close to 1 into 55.55 into 1000 upon 76.48. Just assume that it is 77. Okay. Just assume.
Yes, sir.
Okay. This is the approximate value that you are going to get it. Okay. This is one. Otherwise, you have to do the actual calculations. If it is not, if it is an ABC option, then you will be able to do this one with the help of this one. So this is 55. Now you multiply this number. The 2 digits will come to this side.
Yes, sir.
You will get 55.5. Okay. And 0 means the 3 digit, means 2 digit here and 1 digit here upon 77. You will get 5555 into 10 upon 77. You cut it by 7. 11, you will get 7 za. You will get 11, sorry, 5 za, then 0, 5 za.
Yes, sir.
Okay. Then you divide 50050, they multiplied by 10 and then divided by 7. Whatever the answer you will get that number of millimoles.
Yes, sir.
Okay. So what
Yes,
answer
sir.
you are going to get? 550.
Mm.
Okay. You will get 5050 divided by 7. 7 7 is 49. 1 carry. Okay. Then 515. Then 7 2s are 14. Then 1 carry. Then 0. And 7 1s are 7. Then 3. Okay. Something you are going to get this approximate this value.
Yes, sir.
Please copy this one.
Okay, sir.
One thing I have missed here. One thing is that I just forgot to write this value 10 raised to the power 3 everywhere. Okay. So here will be 10
Yes,
raised to
sir.
the power 3 everywhere. Just do a correction into 10 raised to the power 3 here. Okay. Into 10 raised to the power 3 here. Into 10 raised to the power 3 here. Okay. And to 10 raised to the power 3 here. Into 10 raised to the power 3 here. Or you can write 1000. So this 1000 and 1000 will get cancelled out. Okay.
Yes.
And this time you are getting 721 something value. Okay. 721 this value. But when you divide it by 1000, you will get 0.7 something.
Yes,
0.72.
sir.
Okay. You understood?
Yes,
So
sir.
here the answer in the question is 71. Okay. Let me show you this. We are just getting, without doing the actual calculation, without doing the actual multiplication, we are just getting this value, which is very approximate. It is 7.16. That is 7.2. That will be accepted by the examiner. Okay.
Okay, sir.
Okay. So this 1000 we have forgot it there. Okay, you understood that where does this 1,000 come from? Because it was saying
Yes, sir.
in kilobars. It was written in kilobars and we have to convert it in bars. So I just forgot to write this one in everywhere. So just do the correction here. Okay.
Okay, sir.
And you need to keep in mind that you need to practice this question one or more times and you will get the, you will be familiar with this one. Okay.
Yes, sir.
Okay. Moreover, the Henry's laws constant has some properties. So write some properties over this one, some applications of this one. Henry's law. First of all, Henry's laws means the value of KH is different for the value of KH. The value of KH, which is Henry's constant is different for different gases. Okay.
Yes, sir.
Second point here is that if you increase the value of KH, okay, means the we will
Yes,
simply
sir.
say that the value of KH increases when the temperature increases. Okay.
Yes, sir.
And if the temperature increases, the solubility will decreases. Then the solubility will decreases. Okay.
Yes, sir.
And we will simply say that those gases which have more force of attraction are more soluble than those gases which has less force of attraction between its particles. Okay.
Yes, sir.
So we'll say that those gases are more soluble in water which has more force of attraction,
Yes, sir.
between their particles. Understood?
Yes, sir.
And some gases get easily interact with the solvent. Like for example, ammonia gas, NH3. I told you ammonia, nitrogen, oxygen, fluorine, and chlorine. These are highly reactive. So they attract the bonded pair of electron towards itself. So it will become negative. Okay. This is positive. This is positive. So because of the negative charge, if it's come in the contact with the water, it will easily get dissolved. Okay. Because ammonia gas is polar. So if a gas is polar and we are dissolving in the polar solvent, then it will be more soluble. Okay.
Yes, sir.
So if a gas is polar and it is like carbon dioxide is non-polar. So if you are dissolving carbon dioxide, it will not be soluble. Okay.
Yes, sir.
But if you are dissolving some polar substance, polar gas, so it will be more dissolvable. It will be more soluble. Okay. Like here,
Yes,
you
sir.
can check it. Like we will say that ammonia gas is more soluble, the highly soluble. Then we have the carbon dioxide. Then we have the carbon monoxide. Then we have the oxygen gas. Then we have the nitrogen gas. And then we have the hydrogen gas. Hydrogen gas is least soluble. Okay, the order of solubility. Order of solubility. So if you stuck somewhere, we will uh, check it in the next class. But please try to solve the questions that is going to give you on your assignment that you are going to give on your assignment. Okay, that will be given to your assignment. So do it. And after that,